Hello friends, hope everyone is okay wherever you are. Let's try to look at this wonderful question that we have been given under elimination, which is acid catalyzed alcohol dehydration. So let me try to go through this mechanism with you. Okay, so let me just write it is like this, CH3, then like this, then here C, then here there's CH3, here there's CH3, then here to be C, then here there is OH, then here H, then here like this. So the first thing that you are supposed to do when you are given such a question, you are supposed to protonate a hydroxide. So we'll look at this. You see that this is an E1 reaction. When an acid is when an acid then is stretching like the way it is, you will see that it is a elimination, which is E1 reaction. Now how is it going to be an E1 reaction? Let's try to look at this together, or to go through this mechanism together. So the first thing that you're supposed to do, you know that OH is a bad leaving group. So what you're supposed to do is to protonate an OH. What do I mean by protonating? Is to add a proton so that it can be water and it will be good leaving group so that it can leave. So what am I going to do? I'm going to bring this acid. You know that acid, the way it is O here. Then okay, let me just write it in this form so that it can be better for us to do. So I'm going to write it like this. Okay, so let me even change the color. So it will be like this, H here, then OH like this, then with a positive like that. So this is an hydrogen ion, which is OH there, which is acid there. So remember this, it has got lone pair there, lone pairs. So this for us to protonate it, I'm going to use these lone pairs to come and grab this hydrogen there with an arrow like that. Okay, with an arrow like that. Okay, let me just do this. Okay, I'm going to bring this then and grab this hydrogen, then this bond will go. So I can just show it like this. So make sure it goes where there's what? There's oxygen there. So now when I reach at that point, what am I going to do? I'm going to write like this. This is like that. So I'm going to write like this, Cl3 like this, then here C, then here there's CH3, then here there's CH3, here there's C, then OH2. Remember what we have there, which is OH2, because we have gotten a hydrogen there. Then don't forget to put a positive there. Don't forget to put a positive, please. So okay, so here I'm going to write a positive like that on the oxygen, but like that. So here there is a H there, then here CH3 like that. That's the way it is. So this is what is known as a protonated alcohol. Protonated alcohol. This is a protonated alcohol. So when you reach at that position or that state, what are you supposed to do? Let me just write it, which is like this, C, then here is C, and CH3, CH3 like that one, then here to be like this, and here remember there's a positive here, so you need to write it well. I don't know what is, my pen is not okay. So like this. So here now I'm going to show that this is a good leaving group as now, which is water. It will now go like this. So I'm going to show with that arrow to show that the water has gone, giving us the one which is a secondary. So here to be like this, Okay, then here CH3, then here it will be CH3 like this one, then here with that, then CH3 like that. So let me just lab some, then I write it well. Okay, then how is it? See, then here CH3, then here there is a positive like this. Why? Because it has lost a bond. This bond has gone, and we have a positive charge, which is carbocation on the secondary structure. So this one is a secondary carbocation, a secondary carbocation. So that this is a secondary carbocation. Now when you look at that, a secondary carbocation is not stable. Remember, we said a tertiary carbocation is more stable than a secondary carbocation, and this one is more stable than a primary carbocation. So now you should have that in mind. So when you have a chance to do a methanide shift or hydride shift for you to have a stable cation, please don't hesitate, do that. So now what am I going to do? I'm going to, let me just change the color. I'm going to write like this. So here CH3, then here C, then here CH3, CH3 like that one. Then here I'm going to write like this, CH, then with a positive like that. Okay, let me just lab, then I write it well. Okay, I'm sure the color is not okay. Okay, so let me write it like C, like this one, CH, like the CH3 like this one, then here C, then CH3, then here CH3, then here C, then with a positive, then H like this. So what am I going to show here? I'm going to say, since this one is a secondary carbocation, let me change it into what is known as a tertiary carbocation for me to make it more stable. So what am I going to do? I'm going to show that this bond, which is methanide, it has come here. You see, right? So when this bond has come here, it's going to form something like this. So I'm going to write this to show that this is a transitional state where now it's changing. So here it will be CH like 3 like that one, then here C, then CH3, then here CH3 like that one. So I'm going to show that here there is a CH3, then here it is changing. Let me just show it well. Okay, it is changing CH3 like this. Okay, so here it will have a partial positive charge, then even here it will have partial positive charge like that. So here it is shifting from here. So this is what is known as a methanide shift, and we are on this position, which is transitional state, where now the methanide shift has shifted, and we are showing, I'm showing that here the methanide shift is shifting. We are going to have a partial positive charge, and here the partial positive charge. So let me try to lab on top. Hope we are on the same path. Okay, so now what am I going to do? Okay, so when I reach at that point, I'll say that this now is going to here. So it's just a continuation. You can put an arrow there. You can put an arrow there to show now with this. Okay, so let me just write it well. Okay, so it will be something like this. You can put an arrow there, then here to be C, then here CH3. So make sure the bond is going on the carbon. Then here to be CH. Oh, sorry, here there's no like this. Okay, so here to be C, which is here now we're going to have CH3, then with H here then CH3 like that. I don't know if my pen is writing well. Okay, let me just lab and write it well. CH3 like this one, then C, and here it is CH3, then here to be CH, then CH3. That bond, which is the methanide shift which has taken place here, this has come here. So now I'm going to show you that here there is methyl, which is methyl, then the carbocation is here now. You can see now the carbocation which we have is what is known as the secondary carbocation, and this is a more stable one. That's what we wanted. So now what am I going to do when I reach that position? What am I going to do? I'm going to, let me lab this. I'm going to use the rule which is Z-self as well as the Hoffman rule. So now looking at the base that I'm having, so looking at even the product that I'm having, there are two products which has produced more than one product. So what am I going to have? So remember there, this is it was just a continuation. There was an arrow. So now I'm going to write it well now down, which is now here. I'm going to write it like that. So for me now, I'm going to kill this hydrogen. Oh, sorry, I'm going to kill or to neutralize this carbocation there by either adding a bond here or this side, either which is on the carbon that's around this carbocation. So now it will be like this. So here it will be like this, which is a positive there. Then here, so here I can put like this. Then I'll put the hydrogen there. The one which is here is the same thing. Then here it will be CH3. Then here, here it will be CH3 like that one. It's the same thing. So now what am I going to do? So here it will be CH2, then with the H there. It's the same thing. When you reach at that, it's the same thing. So now I'm going to show with an arrow. Remember, when we are protonating, we are driven with water. So the water, that's the one that I'm going to get. I'm going to get water there, which is like this one, H, like this. Then I can do like that. Okay, so now when I reach there, I'm going to say, if it's a Z-self, I'm going to attack or to obstruct the hydrogen, which is the less exposed hydrogen, for me to have the more saturated alkene. So how am I going to go about that? So I'm going to attack the less exposed hydrogen. So looking at this is the carbocation, which is here. Am I on the right path? I made a mistake. I made a mistake here. Sorry guys. Just on the writings. I made a mistake just on the writings. So I'm going just to write like CH3. It was like this. Then here C. Then carbocation there. Then CH3. Then here CH3 like that one. Then here I said I'll put this like that. Then here I'll put CH3 like that, the way it is. Then here I said okay, I can put like this, which is 2. Then here like this. Why am I putting like that? Is for me for the easy attack of the hydrogen. So I'm going to bring water, the one that I had brought, which is like this. So here, this is the water that I've brought there. Which one am I going to attack for me to have a Z-self product? I'm going to attack the less exposed hydrogen, which is being hindered by the alkyl groups. So this is the one which is being hindered by the alkyl groups, which is the less exposed hydrogen. So when this has been taken, this bond is now coming here to form a double bond. How? It's going to form something like this, CH3, then see like that one, which is the double bond will go. So now I'm going to write like this. Okay, I'm going to write like this to be like this, then C, then here will be C, then here let me put it on top, which is to be like this, CH3 here, then here to be like this with a double bond which has been formed there, then here to be C with this methyl here, which is CH3 like that one, you can see. Then here there is hydrogen with this, now it will be CH3 like that. Then I'm going to say, what if it's so here I can put a plus. What if it's an alkene, or let me just say, what if it's it's a Hofmann product that I want to form? I'm going to attack or to obstruct the one which is more exposed hydrogen. So the same water, if I want, I can write it either here or to get the same here to attack this, which is the more exposed hydrogen, for me to have the less saturated less saturated alkene. So this bond will come here and form a double bond. So what will be my other product there? My other product will be like this. So I'm going to write it like this here. So this one, you can see that here I can even start with the same, just to look at this the way it is here, which is CH2, then will be a double bond, then like this. Then this one, it can be on top here, which is CH3 like that one. Then here it can be like this. Remember here there is a hydrogen, which is C like this one. Then here there is C, which is this one, CH3 with this, which is methyl CH3 like that. So this is a compound that has been formed together with this. So there is G and also H like that. So this is the mechanism that they wanted us to write, and it is 6 marks. So you can go through the same and you find it. So there are some other questions that they may ask you to say, okay, give a reason for your answer. Which one is the major product between G and H? And give a reason for your answer. So looking at that, you can able to tell that the major product will favor it will be the ZSF product. Which one is the ZSF product? It's the first one, which is G. G is the major product because of the base that we have been given. This hydrogen ion, which is a conjugate base, is a less bulky, which will favor attacking the less exposed hydrogen, which is being hindered by the alkyl group, to produce the more stable saturated alkane, or the more saturated alkane, which is ZSF product, and this is G. So G is the one which is called a major product. Now there are some condition that will favor the Hofmann, which is H. This H. So this one is a major product, and this one is a minor product. Then they'll ask you to say what are the conditions that may favor, or that would favor the minor product. So it's by use of what? Since this one is a Hofmann, you can say by use of the bulky base. Don't forget to give an example. You can even give this, which is sodium tetrabutoxide, like this. Sodium tetrabutoxide, which will favor attacking the more exposed hydrogen and giving us the Hofmann product, which is the less substituted alkene. So please, this is how you're supposed to answer. And then I added some of the questions. I'm sure they were there, just that I didn't I didn't put there. Thank you so much.